Hi, I'm Rhonda Zhang, and I'm here at NAB 2011 with Tim Dashwood. Tim is the founder of Dashwood Cinema Solutions. Tell us what's new in 3D, Tim.
Well, we have a new product called Stereo 3D CAT, and that stands for Calibration Analysis Tracker. So what this allows us to do is to actually align a rig very, very quickly. It gives the stereographer all kinds of analysis tools and tools to communicate with directors or people who may not completely understand 3D. It just allows the stereographer to do his job better and actually say, you know what, this is exactly how this is going to look in 3D when we see the final product.
That's so fantastic. So
yeah,
you can show
I can do a demo for you. Yeah,
here.
I mean the first aspect of this is a chart. So oh, do you want me just to hold that? It'd be easier. Okay. So our chart holds an iPad, so we can just slip an iPad in here, and what it has are these unique tracker markers on here. So our software sees the markers and can give you exact dimensions of how much it's out of alignment. We have a fifth marker, and this is our negative parallax marker, and it actually tells, or it can detect whether your wires are crossed. So if your left is actually feeding into your right input, you know, that's one of the most common mistakes. Luckily, it's the easiest thing to fix, but the software will just tell you very quickly, oh, you have an inversion of your stereo and you better fix it. So let's just line this up. What we have to do is step back here. And, okay, I'll just step over here so you can see. So these are the two images superimposed on each other. And as you can see, they're just way out of alignment. Now, for me to try and align this manually, it might take me 15 minutes. You know, on a good day, it might take 15 minutes to do. If it was a brand new rig that I just rented and I just got it out of the box and I'm at the beginning of the day on the shoot, well, my call time is going to be really early because it could take up to an hour to do. So anyway, let's just see what the computer thinks of this. So the computer is seeing the signal, and it's saying exactly how much rotational disparity we have, zoom disparity, vertical, and how much tilt and toe we have, so our toe-in convergence. So it detects all of this stuff. So what it's doing under the hood is it's realigning everything, and it's telling you how much work it had to do to realign all of that. And on top of it all, it actually tells you what your interaxial, what the stereo base is, your interaxial distance between the cameras. So I'm just going to start aligning this rig. Here, I'll give you the mic back. So the first thing I'm going to do, I'm going to start at the top, and I'm going to tune out this, 2.5 degree rotational disparity. So on this rig, what I'm doing is the bottom camera will roll on the axis. So I'm just tuning it. So just, oh, wrong direction. Okay, so I'm just going to get it down in this green zone, and I'm just going to get it really close. I mean, right now I think a half of a degree is close enough. Let's get everything else lined up, and then I'll really fine-tune it with the little knobs. So the next thing I'm going to do, I would do the zoom disparity. If we had prime lenses, we would just move the cameras back and forth, because what it's actually measuring is the field of view, the difference in field of view between the two cameras. So I'm just going to adjust one of the zoom lenses. So in this case, because we're using zoom lenses, you would set up one of your cameras to be the mastered. So this is the framing, the exact framing I want, and then what you would do is just set the other camera to be exactly the same. So I'm just bringing this in, and what you're not seeing here is I'm barely breathing on this lens to adjust it. So it's very, very sensitive because we can actually track down to 1/1000th of a pixel.
Wow.
But we've had to turn the sensitivity down, so it still might be a little too sensitive because I'm worried people might start just really going for it and trying to get it down as precise as they can when it's not really completely necessary. So next would be our vertical disparity. Now in this case, I don't have a knob for that. I would have to actually use an Allen key to do it. So, and I got it pretty close when I first set this rig up yesterday. So I'm going to move on to tilt, and my tilt can be adjusted here on this knob. So what this does is it actually tilts the mirror in the beam splitter. So I'm going to bring the tilt in, and once again, I'm just trying to get it in the zone. I'm trying to get it in that green zone. So at one point it hits 0, and we're set. And now our toe, a little bit of toe disparity. Just going to tune that in. Oh, wrong direction. Okay. And I'm just getting that in the green zone. I'm turning the knob so slowly here because our sensitivity range, the range in here is when you're just really close. So what happens is if you're way out, it just, it redlines, and you just have to keep going until you get it down. So now we're basically calibrated, but we haven't actually zeroed the rig, meaning we haven't put the two cameras on top of each other. So they actually have an interaxial separation. But the great thing is that the software can detect how much of an interaxial separation there is. And it's telling me that we're at 16 millimeters right now. Now that is actually way more accurate than, this ruler. The ruler can be put in and just slid around on a magnet. And so whoever used this rig last time didn't set it up because it was telling me I was at 22. So it's much, much better to have the computer actually give you the empirical data, and there's no guesswork anymore. So the rig is set, and I can adjust the interaxial distance. So I'm going to increase it up to, so I'll just put it right on 15, and then we'll use that as our in our stereopsis calculations. So turn the tracker off. Now what's happening is because I aligned the toe-in convergence to be exactly parallel, that means that my convergence point is actually at infinity. Hence, everything in my scene is in negative parallax. It's all coming out of the screen. It's in front of the screen plane. But that's not the way my final product's going to be. I'm going to do a convergence in post-production. I'm going to do an HIT convergence. Problem is, on my client monitor, I don't want the director sitting there seeing what's coming out of the camera. I want him to see a corrected output the way it's going to look once we're done the post-process. So that's where I go into my geometry controls here. And I'm going to make an adjustment. Let me just reset this. I'm going to make a convergence adjustment. And in this case, I'm going to first just converge on the chart. Now, our chart has little markers on here for positive parallax, and it has holes in it. So you can actually see through and see the background and actually see what your background positive parallax is. And then we have little markers on here. These are 0.7%. That's for theatrical 30-foot widescreen. And we have 2% markers as well for broadcast. So the idea here is that if you're out in the field and you don't have the computer and you don't have the iPad to interface with the computer and do all of that great stuff, well, then you can still use the chart, and you can still just put it up on maybe a trans-video monitor or something, and very, very quickly, I can just look at this, and right now I can tell you that my separation is about 2% with this convergence point, because it's a really deep depth bracket. My depth bracket is going back, I don't know, probably 30 meters or so. So it's really, really deep. This might be, exceeding my parallax budget for the big screen, but this would work for broadcast right now. But we have an empirical way of looking at this, and that's called the parallax inspector. So I'm going to bring up the parallax inspector, and at the moment it's set at 1%, which was a custom limit that I had put in here. But I'm going to say use the calculated limit, and that's based on my screen size. So right now I can set it to a 30-foot wide screen, and the amount of pixels that represents is in relation to what my resolution is. So at the moment I have it set to 2K resolution for doing a DCP master. So the great thing is now I can take this and look at my parallax back here. So there's like something over there in the Sony booth, and obviously it's the separation is way outside of that 0.7%. So what I can do then is readjust my convergence point to get it within limits.